here in problem number 83, we have four terms, and there's nothing common to all four. We're going to try to factor this, and notice, first thing we ever do is look for common factors. I don't see anything common all the way through here. There's a z, I got two z's, a z and a z, but there's an a here and an a here, and no a's over here. There's nothing common all the way through. So here's the alert. There's four terms, and I see that in the first two, what's common? A 5 and a z. So why don't we do this? Let's group together the first two and then the second two. In the first two, what's common here is a 5, and there's two z's here, a z here. Remember, it's always a smaller exponent. The first term in this group is positive. So we're going to remove a 5 and a z. In the second group, what's common is, this is a z, this is a 2, so be careful. What's common here is an a, so what we're going to do is factor out the a, but notice that the first term in this group is negative. So we're going to take out a negative a. So let's do this. We're going to get 5z, and then if we take out a 5z, what's left here is the 5 was removed, that's gone. There were two z's, we're removing one of them, so there's a z left. And then over here, 5 times what is going to give us a 10. So we do that little division. Positive 10 divided by positive 5 is plus 2. And there was a z, but we removed it. So what we're left with is z plus 2. And now in the second group, we're going to take out that negative a. Remember, we're using a negative because the first term in this group is negative. So we're going to take out a negative a. Negative a. So if we do that, here's what's left. Now, here's that first term in the group. We took out the negative a, so what's left is that z. And then over here, let's be careful now, it's negative 2a. We're taking out the negative and the a. So what's going to be left here is that positive 2. Now think about this. What we're doing is this. Negative times what will give us a negative? So it's got to be a positive, right? Can't be a negative. That would be a negative times a negative is positive. So if we're taking the negative out, we're going to be left with a positive. Negative 2a divided by negative a is positive 2. And look, these things always work like this. If they're going to be factoring by grouping, we're going to group like this, and then what we're going to see is something common. That common element has to be the same in both. So if I got a z plus 2 over here, I'm expecting a z plus 2 over here. And if I got a z minus 2, that's going to be an alert, and I'm going to rethink that. So now what I see common is a z plus 2. So let's take out that z plus 2. And if we remove the z plus 2 here, what's left is this 5z. And if we remove the z plus 2 over here, what's left is that negative a, or minus a in this case. So here's our factored form, z plus 2 times the quantity 5z minus a. We're going to factor this four-term expression here in problem 91. And notice that, okay, I got four terms. I'm thinking factoring by grouping. And let's just be sure here. What about m's? We got m's here, m's here, m's here, but no m's here. So m's are not common all the way through. We've got p's here, p's here, p's here, but no p's here. So p's are not common all the way through. Now with the numbers, I got a 25 and a 5 and a 5, so 5s are common, but no 5 over here. So factoring by grouping just may work. So let's give this a try. So let's do this. So we'll take out a 5m squared, and removing the 5m squared, 25 divided by positive 5 is 5. There was an m cubed, 3 m's, but we're removing 2. So there's 1 m left. And then in the second term, it's negative 5m squared p squared. So there's a negative 5. So negative 5 divided by positive 5 is negative. The 5 was there, we removed it. The m squared was there, we removed that. So what's left is a p squared. Didn't mean to write that big line. Now in the second group, let's take out that negative p. And if we remove the negative p, we notice this. In this term here, negative 5mp divided by negative p, negative divided by negative is positive. And if we remove the p, what's left is that 5m. So we're going to have a 5m. And then in the second term, positive p cubed, there's 3 p's, we're removing 1, so there's going to be 2 left. But notice that it was positive divided by a negative is going to give us a negative. And this is what we are expecting, isn't it? Because we know how these problems are written. This one here should be the same as this one here, so that we have something common, and we can factor that one out. So let's go ahead and do that. So we'll have 5m minus p squared. Now we're taking this out of both of these, so here's what's left. 5m squared. And then, if we remove this, we're left with that minus p. And there's our factored form. Number 93 is going to give us a little bit of a challenge here. Notice, first of all, that there's 4 terms, so we're thinking factoring by grouping, but there's nothing common to all 4. There's a y, no y. There's an x, no x. So let's try factoring by grouping. But now, like we've done before, it's not going to do us any good to group together the first 2 terms because there's nothing in common. There is something in common in the second 2, right? A 2 and a y, but not in the first 2 terms. So maybe we could try this. Notice this now. In this first term and this third term, there's a y common. So why don't we just try that? See where it goes. So let's make that grouping, and what's common is a y. Right, I got 2 y's here and only 1 here. So there's a y common. The first term in the group is positive, so positive y. And in the second 2 terms right here, there is, now I'm looking at this one and this one here. What's common here between 16 and 2, let's squeeze it in up here, is a 2, and there's an x in each one. The first term in the group, right, here's our group, this right here, the first term in the group is positive, so let's be taking out a positive 2x. So let's take that y out. So if we remove this y from here, there's 2 y's to begin with. We're removing 1, so there's 1 left, and then we're going to remove it from here. So take the y out of here, and there's an 8 left, so y plus 8. Then, in the second group, we're taking out this 2x. Now remember, the first term in the group is positive, so we're taking out a positive 2x. And if we take out a positive 2x, what's left is this. 2 times what? Right, 2 times what is going to give us that 16. So we do that little mental division. 16 divided by that 2 is 8. Now, there was an x, but we removed it, so what's left is just the 8. Now, let's go over to this term over here. Take out that 2x, take that out. What's left, you can see, is what's left is a plus y. All right, now look at these 2 terms right here. Y plus 8, 8 plus y. Those are the same, right? Because addition, this is addition. Addition's commutative. You can change the order in an addition. So let's write this as y plus 8. I just like to write it where the variable appears first. So what I'm going to do, since there's 2 terms, I'll use parentheses. I'll take out a y plus 8. And if I take out a y plus 8 in the first, what's left is that y. And then over here in the second, if I take out that y plus 8, what's left is this plus 2x. Then I think we've got the factored form. Now keep in mind, it doesn't matter which way we write these terms. I could write like I've done here, or I could write this if you wanted to. We could write it as, let's get the pen here, y plus 2x, y plus 8, because multiplication is commutative. In 95, nothing is common all the way through, right? M, no m's here. P, no p's over here. So let's try factoring by grouping. Now if I try the first 2, I see there's an m in common. I'm sorry, if I try the first and the third, there's an m in common. and the second and the fourth, there's a 3 common right between the 6 and the 15. I could try that. I could try the first and the third and the second and the fourth. The first two, there's nothing in common. The second two, nothing in common. But let's try this. Here's what I noticed, too. In the first and the fourth, there's a 5 common. Why don't we just see what happens here? There's a 5 common here. And in the second and the third, there is a negative 2 and a p common, right? The negative comes from the fact that the first term in the group is negative. So let's try this. Let's take a 5 out of the first. We're going to be left with an m. And then take a 5 out of here. 15 divided by 5 is plus 3. And then let's take out this negative 2p. So we'll get minus, let's try this, minus 2p. And if I do that, here's what's going to be left. Negative 6p divided by negative 2p is positive 3. And then over here, negative 2mp, take out that negative 2p, what's left is a plus m. Negative divided by negative is positive. So plus m. And now, just like that last problem, what we're left with is this m plus 3 and a 3 plus m. Those are the same, we know, by the commutativity of addition. So let's take out an m plus 3, and if we do that, what's going to be left is this 5, right? Take this out, what's left is that 5, and then that minus 2p.